hey, any of your IT admins can kill people. And that is a privilege that you have given them fundamentally by having this leap.
Hey everyone, welcome back to the Security Engineering Show, the #1 show for security engineers by real security engineers. I'm your host, Noah Stanford, joined today by Foulds-Cook, a super talented security consultant working at Volkis. Our story today is titled Something in the Water, and it's about an offensive security engagement for a regional city where Finn was able to go from simple internal network access to full DC compromise and eventually SCADA compromise, which could have allowed him to release chlorine into the water. Needless to say, that would not have been so good. Today's story is very technical and should offer a lot of insights into modern offensive security and breaches. Thanks for joining me today, Finn.
Yeah, thanks for having me. Looking forward to diving in a bit deeper into this. It's always fun to talk about.
So let's talk about how this got started. How did this end up on your plate?
Funnily enough, this came basically across our scoping team, and they went out and they were like, does anyone want to go to this regional city? And I was the only one who put my hand up for the travel because it is in the middle of nowhere. No one wanted to be stuck in the middle of Australia in a small town. But I'm big into internal security and testing stuff on site. I enjoy that type of work, so I was keen to go.
How did the engagement start? It sounds like it was an offensive engagement. And what was your initial access like? What was your context for the network, essentially?
So generally my approach is sort of just assume nothing. I have talked to some other people that like to start with credentials, but there's enough Windows stuff that allows you to get credentials anyway, so may as well give that a go. But yeah, basically just, hey, set us up on a desk, give us a network port, tell us any IP ranges of stuff that we shouldn't be hitting too hard if you have any legacy stuff or anything super important. And that's about it. And then try and figure out what to do.
Definitely push over a water jet machine or something without the context, right?
Yeah. This network was segmented in a way, which is good. But there are some networks that we've been on where if you look around, you just like spot like X-ray machines or like manufacturing stuff, and you're like, yeah, I can get why they don't want me just running very loud, heavy network stuff against critical machinery.
Yeah, I think I've seen the example in the past of actually somebody using a network scanning tool like Nessus and it actually hitting a piece of critical infra and essentially damaging a part that was being built. Hundreds of thousands of dollars for the part like being interrupted mid-print, which was insane.
There's a lot of like mining industry in Australia, similar kind of thing. If you're in that spot where you have control over that machinery and you're like, how much would this cost if I stop it? And they're like, oh, like 15 grand a second. You're like, yes, that I don't want to touch that.
Right. So you guys get a desk. You're just like any other employee from a technical perspective at that point. Talk me through, what was your initial recon on the network?
Kind of the joke is like we're less than an employee because at least an employee has credentials.
Right.
But we're literally just a device on the network. Generally, there's a few different things you can look at. So when you set up your IP and like connect to the network and basically say, hey, like give me an address, usually it will tell you stuff like what DNS server you should use. And depending on how the network's configured, it will also sometimes tell you like an internal direct domain to like search. And then that's usually just the domain name of the like internal Active Directory. So in this case, that's what happened. So basically, I was looking at that config, could see that they were like, hey, here's the internal domain to search for. Once you have that, you can basically query the DNS server. There's like a fancy lookup you can do that basically spits out what the domain controllers are for a given domain. So did that, saw the domain controllers, was taking a look, like some of them were kind of like in the same IP ranges. So the next thing I like to do is basically go, hey, you can use a tool like netexec, which is rest in peace cracked map exec, but basically you can just give it an IP range and you can tell it to operate over SMB, and it will just go through and scan all the hosts and spit out host names, spit out what Windows version they're running. So I was like, okay, well, the DCs are in the same range, I'll just hit that, and then that basically gave me a giant printout of all their Windows servers.
So after you've gotten some information about what's on the network, what did you find? What was one of the glaring things that stuck out to you? It sounds like mostly a Windows network.
There's always stuff that's scary on Windows stuff that people, if you have it configured, Microsoft doesn't hold your hand as you go for that through that configuration. So the first thing we like to look for is everyone's favorite Active Directory certificate services. There's another one I like to look for sometime, which is SCCM, which is like the configuration management stuff. Basically, I spotted those two. Definitely was very interesting. One of the things is that you can kind of guess some of the stuff in ADCS, but the easiest way is to interact with it is if you already have user access. So in this case, classic like spinning up Responder, spinning up Man in the Middle 6, both tools designed around poisoning network traffic and convincing machines that all of their traffic should route through me. So Responder does that by just responding to these really cool name query searches that Windows computers do, which is basically if they can't find a machine, they're like, hey, does anyone around me know what that machine is? And you just say, yeah, that machine's me. That one's really fun. And then the IPv6 one is the Man in the Middle 6 targets IPv6 because no one configures that interface. And there's two interesting things about that. First, Windows prefers the IPv6 DNS server. So if you have IPv6 set up, it will use that. And the second thing is that anyone on the network can broadcast out, hey, I'm the IPv6 DHCP server, here's a config. So basically you send that around, you set up the DNS server, suddenly machines are looking to you for host names. You
What
can also
could go
then
wrong?
Yeah, what could go wrong? You can also then set up the WPAD DNS entry, which basically says, hey, I have a proxy configuration. And then the machine's like, yeah, just give me that. So they start all just proxying all their traffic through you, which is really handy. Obviously, like you're not going to get anyone's Facebook. It's all encrypted and signed and lovely.
Not the days of ARP spoofing and DNS spoofing with the SSL strip, right?
No, there's sadly
Long gone.
no more Fire Sheep in the browser to see everyone's logins.
Oh.
But yeah, that's basically once you start disempting traffic, now it starts to be free reign. One of those things, those ADCS features, is web enrollment, which you can actually check for pretty easily without having any authentication. And basically, you can just go to the specific endpoint, and then if the server basically responds web NTLM auth, you're like, it supports this feature.
Yeah, which is interesting because I think for a lot of folks that I've seen in the past that do, and for context with ADCS being basically the Windows go-to certificate authority, what I've seen a lot of people do in the past, especially at enterprise companies, is use it as an API. They'll use that web enrollment interface as an API, even though it's generally meant to be like an interactive GUI type web page. So it's interesting. I think a lot of people set this up without ever thinking about what it can mean.
Yeah, well, it's crazy that like Microsoft has like a document which says, hey, if you have this thing on, here's how you configure it to have security built in. It's like a couple checkboxes. It's not hard. They just don't do it for you. And so if you don't do it, you're pretty much stuffed from my
Secure
point
by
of view.
default is gone.
That's a crazy idea, and Microsoft doesn't want to do it because legacy is hard, I guess. So basically spotted that, which is always fun for me to see, not fun for them. So I'm relaying at this point, like capturing some user authentication flows, seeing some NTLM auth. That gives you nice password hashes, not in like a super brute forceable. The hash strength is like moderate. So at this point, I've identified ADCS web enrollment, which is great. I'm also like grabbing people's authentication flows. So that whole poisoning traffic thing is working amazing. Part of that is it's giving me like net NTLM v2 hashes, which are crackable. They're just a bit slower than we would like.
Why crack them if you can pass them along, right?
Yeah, like ideally, my first preference isn't to go crack them because that can just take a lot of time. So I'm capturing this traffic. The machines do have like SMP signing on. So these packets have integrity checks. But in the default configuration, web enrollment basically doesn't have signing, and so it just ignores that part of the packet. So I'm capturing these like user authentication, and I'm just like, okay, I'll just send these to web enrollment and ask for the user template. I'm making an educated guess here that they probably didn't disable the default user template. But yeah, that just gives me a certificate. With that certificate, you can do some fancy Coerced PKInit stuff to basically convert that. The general idea is that in usual configurations, you can use that certificate to authenticate to LDAP, and you can use that to authenticate to some services, but not everything, which is kind of annoying. But through some fun Coerced trickery, you can basically convert that into the hash for a user, which then works for every service because yeah, that's just basically the hash version of the password. So that gives you access to SMB. That's everything.
So it sounds like from that, you end up enrolling, you assume the user cert's actually still enabled. Luckily enough, it is. It takes your authentication from responder and actually gives you a cert for that user. What's next?
Now you have credentials. Everything on Windows will talk to you. Everything loves you. You can do Bloodhound. You can do big LDAP queries. You can start looking at everything on the network, which is so nice compared to when you start off with no credentials and everything kind of ignores you. And knowing that there is web enrollment, though, there's this nice little thing, which is the kind of fundamental idea of, hey, if I can capture an authentication flow that's coming to me, I can send that to the ADCS server and it will ignore the integrity check and it will give me a certificate representing that user if they can enroll. And so some nice fellows a few years ago released a tool called Coerced, which is generally targets this class of vulnerabilities. Some of them are more famous than others, like Petit Potem, Print Nightmare, this kind of stuff. And they generally follow the concept that with a low privilege user, you can basically go to a Windows server and say, hey, I need you to authenticate against this arbitrary machine. And those work in different ways. So one of those calls, for example, is basically saying, hey, domain controller, I need you to encrypt this remote file system. It's running on this SMB share that's on my machine. And the DC is like, okay, I'm going to check if you have authorization to do that, if you have permissions. So I'm going to go to the server and check what your permissions are on this folder. It gets to the server and the server's like, I need authentication. And the domain controller's like, oh yeah, sure, here's my machine authentication. Great feature. Nothing wrong to see here. Microsoft has marked most of these as won't fix, which is lovely.
It's fine. It's a feature. It's not a bug.
Yeah. Microsoft will silently fix some of these. So obviously they recognize that this is a problem, but they also say that they won't fix them. It's a weird spot.
It may be conveniently used in other places by various partners.
Yeah. It's wild. But generally, like, I'm sitting at something, it's like, hey, I can capture any machine in this case, well, any Windows server, basically, and I can get that to authenticate against me in one hand. And then also I have a ADCS form that allows me to convert an authentication into basically a hash representing that object. Obviously, you want to chain these things together. So at this point, I actually looked at the certificate templates enabled in ADCS, because now once you have LDAP query permissions, you can actually look at that. Most places have a custom certificate for the domain controller anyway. So even if they disable the default one, you'll probably find one that's like domain controller Coerced authentication or something. That's like, I don't know why you didn't just use the default one, but sure. In this case, default one's still enabled. So I'm like, okay, let's set up like a tool to relay authentication targeting this domain controller template. Let's coerce the domain controller to authenticate against me, relay that through, and that gives me the empty hash of the domain controller.
Yay, we're now the DC.
We're now the DC.
What can we do?
What can we do? DCs actually have less permissions than you might expect, but they do have this one really important permission, and that's the ability to DC sync. So if you turn a DC off and then wait 2 weeks and then turn it on, that DC probably is missing a bunch of the changes that happened. And so it has to have this fundamental process of going, okay, how do I get those changes? How do I synchronize my database with another domain controller's database? And so to do that, obviously there's no manual user interaction. These things just happen automatically. And so the domain controller uses its own machine account to perform all those processes, which is what we have. So we can basically create these queries and say, I need to synchronize something. The normal sort of naive way of doing this is to just say, I would like to synchronize the entire password database right now over the network.
No one will notice.
No one will notice except for every EDR and Windows Defender for Endpoint, which will also probably block it. That's great. Doesn't usually work now. It just gets blocked. But one of the things that usually does work is if you just target like a single user, that's not flagged. It's not looked at as heavily.
Yeah.
So in this case, I have LDAP, so I can look at and go, give me a list of all the domain admins. I was sitting at a desk, so I sort of like turned to the IT guy who I'd had a couple conversations with and like, can I use your DA account? It's all good. And he's like, yeah, that's fine, with like a tear in his eye.
Not
yeah,
me.
so basically synchronize his password hash, and then now I can impersonate him to the entire network. So that's, everything is compromised. Everything's on fire.
I think it's interesting because the big thing that EDR would be blocking here is the ability to synchronize the entire domain. Like you said, it's the noisiest thing you can do, but normal operation can't be blocked, right? Or your domain's not going to function anymore. So there has to be some mode of
Yeah.
operation where it works. And that mode of operation is regular, small, incremental changes. So if you are able to just cherry pick one user and do the right thing, you can get the data without tripping up some EDR on a noisy signal.
Yeah, some are a little bit smarter than others. So, for example, if a DC Sync request originates from an IP that's not a domain controller, maybe that's suspicious. So some things will actually flag on that, which is good. There are obviously like more steps and more things you can try and do to get around that. But in this case, that was sufficient basically to skip all the alerts, alarm bells that they had set up. So domain admin, one of the things that I've definitely focused on and learned, especially being at my role where I am currently, is DA. If I got DA in a report, not really going to convince anyone to do anything.
Yeah, that means very little operationally.
Means very little. So contextualizing this risk and finding impact, very important. DA is not the end. So most networks these days where I see a domain controller are usually moving towards hybrid. Historically, if you go back 6 years, all of the single sign-on solution for cloud was based around ADFS, which is the Federation service, which was cool. I've only seen that maybe twice, so it's a little bit rarer these days. So basically, you can use this nice new tool called like Azure AD Connect, and it has kind of like 3 different modes of operation. And the one that pretty much everyone uses is pass the hash. So basically, that's where the service will, when people change their password locally, it will synchronize those passwords up into the cloud. First thing to do, find the Azure AD Connect service. Luckily, it was on like company name Azure AD 01.
What could this be?
What could this be? Yeah. So shell over to that, have a good look at it. Basically, there's a couple modules. Generally, the idea with how the pass the hash works is it creates this super special account in your Azure tenant, which is like sync underscore a bunch of random characters and has like the host name of the machine that's running it as well. And that account has too many privileges. And someone reported it to Microsoft and said, hey, it doesn't need these privileges. Please remove. And Microsoft said, feature, stamp, will not fix, won't fix.
We need the designated feature Bible of Microsoft to understand what's a guaranteed red teaming technique or
yeah. So previously, if you had that, it used to be able to just change the passwords of every user in your tenant. So the thing that synchronizes local users to the cloud could change cloud-only users' passwords. Why? That's nothing. It never needed to do that. So basically, jump on the server, I use AAD internals, had to do a little bit of stuff to get the AV to go away and stop paying attention. There's cool tools like EDR Sandblast, which will basically intercept AV like alert messages that are going back home and just like block them. Yeah, it just stops it from communicating back, which is great. And then my favorite for Microsoft stuff is you just like disable Defender.
I'm curious on the Sandblaster tools, like how effective is that? That seems like it's something I've thought about too, is like if you have access on the device and you can legitimately just make sure the agent can't communicate home or phone home, what can you do? Like, is that very effective or is there some route around that?
Yeah, I used it a week after it came out against insert popular EDR product here and basically did that, and then they got 0 alerts. So previously, every single time I tried something, it would get blocked, and then there would be an alert on the server being like, this is really bad. After that, it would get blocked, but the server would have no idea. So it wouldn't be communicating back home, which is a very, very effective technique. I'm pretty sure, I hope, that if you try and run those tools, that the EDRs will get mad at you now. It's always a cat and mouse game. So I hope someone's just signatured them all and tried to go about like stopping it. So set that up on this box, used AAD internals, so I didn't throw any alerts, and basically got that special account, that synchronization account, got its like username and password. From there, the special cool privilege that we want to exploit is that account can add password credentials to enterprise applications. So basically in Microsoft Azure land, you have an enterprise application, and then when you give that thing privileges, it actually has like a service principal, which doesn't really tell you, but like that's actually the account that's kind of like getting those privileges. And then if you can add credentials to that, you can basically pretend to be that like service principal and do things that it has permissions for. So people set up really cool applications. The biggest one I've seen pretty Australia-wide is like Manage Engine, which I have a gripe with because they know how to fix this but don't. And their default configuration is they're designed to back up Azure AD. And so they have read-write on everything. And so if you add a credential to that, you can basically use those privileges. I had one client, I was on site, told them about this issue, they contacted, and they were like, oh yeah, you should add MFA to this service principal if you were curious about the fix. I'm just sad that they don't tell everyone to do that from default.
Right.
It's one of those
Right.
things. You need to look into it and you need to understand that this is a
When
risk,
setting
which
up
makes it
the
really hard.
application, like, hey, we're going to create this administrative user new tenant. Please add MFA to it immediately.
Yeah. Why not? Like, what could go wrong? In this case, basically just add a credential to that. And then as soon as I got that, I could use that to query the Graph API. So I queried the create user endpoint and then made my own Fin pen test account and then queried the add role to user and said, give it global admin. And then logged in, went to the roles page, took a screenshot of me having global admin. Yeah, that's pretty big impact because that's basically their entire everything cloud is gone.
From
Which
DA
is
to GA
scary.
to BA.
Yeah.
So now that you've got GA, it sounds like you've got pretty much the entire infrastructure of the environment. What's next to prove out impact?
Yeah, well, one of the good things is, unlike a red team, I'm trying to work with the IT team to highlight impact and give them stuff. So I turned to my IT admin and I'm like, hey, this is what I've got so far. What are you most scared about? Have a conversation, say hello, actually try and figure out what they're worried about. And yeah, he was like, that's very scary. The only other thing I'd be worried about is our SCADA. So they have some machinery, specifically like manage a town area. So they have stuff like water supply, sewerage management. They have some HVAC systems, and that's all managed through SCADA. So they're like, no hints, but SCADA is what we're worried about. And I said, okay, very good. First thing I did is I went to my giant list of all the host names. At this point, I had used, rather than just the list I got by like going through that range, I'd use like AD DNS dump, which basically will dump everything that is in there, which is very lovely. And I searched SCADA, good place to start. And I see like SCADA indicators primary, SCADA indicators standby, SCADA jump 01. I'm like,
What are these?
what are these? I wonder how you would pivot into this other network. Now, there was actually a separate issue, which was that they had basically misconfigured some of the firewall rules. So from the network segment that I was in, I could just go straight to the jump box, which they were like, this definitely shouldn't be the case. The other way of doing it, which I kind of demonstrated to them so they can understand it's still like possible, is that they all have these separate admin boxes that they do stuff from. And those admin boxes are allowed to talk to that device. So I basically just went to an admin box, shelled in, used a reverse SOX 5 sort of idea, which is basically where like a SOX proxy lets you tunnel any arbitrary traffic through. And so the idea is you spin up like a small client binary and that connects back to your server. And then when you send SOX traffic to the server, it tunnels through and then the client like does that for you, gets responses, sends it back. So you can kind of like tunnel straight through devices. So use that to tunnel through one of the admin's machines straight to the jump box. And then obviously we're DA at this point. So just RDP in. You might be wondering like, oh, how did you RDP in? That requires a password. We cracked quite a few passwords. At this point, it's also like we also had NT hashes of everyone, which is, yeah.
That time as DA and GA, you can also just go into ADOC or Azure and like reset the password for any user you want to be.
Definitely.
Noisy, but
that's
it
always
works.
the thing. Like you can also create your own DA. I think we ended up cracking like 60% of passwords, quite a few DA passwords. So if I can use one of them, why not?
So you guys were on the jump. You found a standby server, presumably, hopefully, non-production, and then what seems to be the prod server.
Well, so I got on the jump box and I said, I'm not touching this with a 20-foot pole unless I can talk to the SCADA guy. Next morning, we went on, like, drove out to the actual site where the SCADA guy sits, sat next to him, and basically I was talking to him the whole time, being like, can I do this? This is my idea. Can I do it? Will it cause any impact? Because knowing what's running on these things, I didn't want to have any downtime or cause any issues. Verifying with him, I jump on a standby server. One thing to note is all of the standby server configuration is replicated to primary. So he was like, definitely don't touch config stuff. But basically, they were using a product, I think it was like SCADA or something. I tried to figure out some documentation. I think I pulled the database from it, like a database backup, and no one has written a parser for that database backup. So threw my hands in the air. And yeah, I couldn't figure out. From basic reverse engineering, like that would be like, maybe if we were doing a red team and we had like a month. Maybe.
Yeah, random binary or whatever format that's encoded X way, Z way, Y way. It's not worth trying to find out the arbitrary shifting that's happened in the data there.
I was really hoping it would just dump like a SQLite database, and then
right. Here's the insert statements.
Yeah. But no. So staring at this, reading some documentation, I'm like, okay, well, what's the emergency process here? If we lose access to this and we need to get in, what does it do? And funnily enough, they add a feature, which is very lovely, which is where you can rerun the installer and you can change the password of the super user account. And I'm like, that sounds really handy. So I turn to the guy and I say, hey, this is what I want to do. He said, yeah, that should be fine. Rerun the installer, add my own password to the super user, wait for that to come up. Try to run it. I get this T licensing server error. And he's like, haha, this is where you have to have domain knowledge to figure this one out.
You need the special information.
Yeah, you need to really know what's going on. So I open up the services and I find a service that says like licensing service, and I start that.
Could this be?
And then it worked.
I found the special information.
I did it. I'm a true hacker now. So once the licensing service was spin up, I can connect to the standby server, and then full graphical user interface renders. And I'm looking at the water supply controls. I'm very scared. I don't want to click buttons. I don't want to do things. But I'm giving it a good read. And I'm like, there's the chlorine tank. And I'm like, okay, so if I wanted to look at like a sub menu, how would I do that? He's like, oh, you click on this thing. I'm like, cool. Open that up. And then I'm looking at like the button that's dump all chlorine. And I'm like, yeah, what would happen if I click that? And he's like, oh, we'd probably have some safeguards. No, that would probably just work. I'm like, so that would just dump chlorine? He's like, yeah. And I'm like, would that be dangerous levels? And he's like, yeah, that would kill people. I'm like, makes my job a lot easier now. Normally I've got to write this report, find all this other impact, talk about how I got access to files and financial data. Now I just get to write, I can kill people, full stop, impact statement done, go home.
It's interesting because when you change that from obscure technical thing to like, yeah, I figured out how to use the thing that you set up to kill people. And they're like, oh, okay, well, you have my attention. What is that issue? How do we fix that? From the start, looking back on it, it seems like there were so many steps in the exploit chain here. What do you think would have been some of the most preventative actions they could have taken along the way?
Disable ADCS web enrollment, or at least turn on the protections. Number one, just do that. You'll save yourself so much pain. The next thing is probably fixing coerced authentication. Another thing that will just save you so much pain. It's hard to fix. In fact, this is going to be a tiny bit of a shameless plug, but one of the only ways you can fix it is basically by implementing firewall rules. So there's actually a GitLab repository under my company, which is Volkis, and it's like it's client scripts. And we have a folder that just has these RPC filters that block these pipes. And yeah, that's basically the only way to fix coerced auth, which is crazy. You have to do like netsh space TACF, basically to say implement these firewall rules, and you can read them. They're pretty easy to read. That's a lie. They're terribly confusing, which is why it took my boss when he originally wrote them like a couple days to figure out how it was supposed to work.
Yeah, I was gonna say they're publicly accessible, but it's better they're not locked behind like some EDR firewall as this nice preventative feature we've created.
Yeah, I mean, this is just like an open solution that uses tools that everyone has, right? Windows Defender, Windows Firewall is on every server. So it's always there. You can always do this. So that's nice. There are EDRs that block a lot of coerced authentication. Not all. So some techniques still get through, some things still work, but usually it's getting a lot better now. Yeah, ADCS stuff is also not well signatured. So the one I talked about, there's like different escalation techniques, but that one's specifically like ESC8, which is the web enrollment one. These guys were vulnerable to some of the other ones. I just didn't go through exploiting them. I definitely highlighted them in the report and said, this is terrible. But for example, they had ESC1. So like every domain computer on the network could basically request a certificate for any user. and it's not hard to get a domain computer's hash. So there's stuff like that, which is definitely like hardening ADCS. If you have it, you need to go put time and make sure it's hardened, because it will very quickly be a one-stop shop for escalating privileges to domain admin.
What do you think was the most insightful about this for you?
I always get a little bit scared when you find stuff like this. It's always a bit tricky. Teams are pretty small usually, and IT teams don't have good information, especially when it comes to Windows and Active Directory, about stuff that they have to harden. Because if they look up a hardening guide, what they usually get is 1,000 different findings of what you need to harden, and all of them are just kind of put with the same priority-ish, or maybe just high, low priority. And it's really hard to sit down and filter out, okay, what is stuff that's, if someone abuses, is going to instantly compromise our network, and what is stuff that's going to stop someone from running Bloodhound or something. I don't know.
Right.
It can be very hard to sort of figure that out. And yeah, I mean, also generally a lot of this advice just isn't passed around very well. So we find these issues over and over, and no one really talks about them as much as they probably should. So you find this thing and you're like, that's a very big vulnerability. And then you go to the next place and it's just the same thing. It can make it a bit repetitive, a little bit boring, when it's the same vulnerability over and over.
The same path every time.
Yeah, but I mean, like, places are starting to identify this. I'm not sure if it was the NSA or the cybersecurity one in the US, but they published their big, hey, we do security testing of the government. Here's our list of things that we think are high risk you should fix. Category 1, misconfigurations. First dot point, ADCS web enrollment.
Right.
So it's definitely a thing that is slowly coming up in awareness. I hope that in like a year or two that it basically just doesn't become an issue. That's my hope, but we'll see.
We usually ask, if you had one message to security engineers watching, what would you tell them? Whether it's red teamers or blue teamers, what do you think folks could take away from this?
Well, two things. Is there's the part with SCADA, and then there's the part with getting DA, right? So the first thing is go look at ADCS, go figure it out, because that's tier 0 server, and if it's misconfigured, you're done. And the second thing is, please don't domain join your SCADA servers. Please work with someone to think about how you can isolate these things as much as possible. Because even just at a privilege level, hey, any of your IT admins can kill people. And that is a privilege that you have given them fundamentally by having this leap. Once you start talking about that stuff, people start to realize the issues. But if you've got machinery, have a think about, this is your IT dude or your IT admin that you're asking to administer the server. But that also means he has admin over SCADA. And is that something that you're understanding? And then if anyone gets admin, they also have admin over SCADA.
As silly as it is, a sticky note somewhere seems almost less dangerous than unfettered network access, being able to escalate to it from DA, right?
Yeah, I had a good chat with the architect for that thing. And yeah, he was like, originally, it was a laptop which had the radio access, and you had to go to that laptop, and then that would radio in. Laptop wasn't connected to anything else. It was just by itself. So you'd log into that, probably with a sticky note, to be honest, with the password. And you would use that to get access. And yeah, that is more secure than having a system where with one hop, anyone in the network can instantly start getting over to a jump box and then start talking to it directly and then start doing scary stuff.
Well, thanks for coming on today, Fen. This has been an awesome story. I think it's very rare folks get to hear the inside of, you heard in the news, I could have poisoned a town's water supply, or I could cause this dangerous thing from the hack I did. And it's rare folks get to see the full path of, I got on your network to now this is the end thing.
I'll add one more piece of insight for pen testers, which is please try and write good impact statements. Because I think in the looking for impact, sometimes you find the most interesting design choices and vulnerabilities. Sometimes these things aren't necessarily vulnerabilities. They're just not meeting what the person actually expects from their network. You're finding that difference between expectations and reality, which is the expectation is one SCADA dude who administers these servers can change the configuration. And then the reality is it's that dude plus every IT admin plus anyone who gets admin. And once you start exploring that stuff, you can start actually addressing some of the real problems there, because they can go and fix some of these vulnerabilities. But as long as that leap is there, this is always going to be an issue for them. As long as someone can go one step, they fix Coerced Auth, they fix ADCS, but there's some new novel administrator method or way to get DA or new vulnerability, and suddenly they're in the exact same place they started.
Thanks again for coming on, man.
Yeah, thanks again for having me. It's always good to talk about this stuff. I think awareness always helps.